Okay, Assalamualaikum and good morning again. Sorry for the hiccup. We had a small connectivity problem. Alhamdulillah, our technical teams has fixed the problem. I would like to repeat myself again. Thank you again for tuning in and joining us in today's episode of Insights Humanizing Innovation Session with Industry webinar series, or simply Insights High Session, live here on MMU official Facebook. My name is Azlan. I'm a lecturer at the Faculty of Engineering and Technology, Multimedia University, Malacca campus. I'll be the moderator for this live session titled Telecommunication Industry and Quality of Life, Where Are We Heading? This session is organized by Industrial Collaborations and Engagement Center, ICEC, and co-organized by the Faculty of Engineering and Technology, MMU Malacca. Just a little housekeeping before we get started. First, I would like to ask all of you to like and share this page. We want to reach as many audience, the general public as possible, at least within the academic communities. Second, if you have any questions during the presentation, hopefully along this topic, please type them first into the chat box. I'll bring them up during the Q&A session right after the second speaker. Now, I would like to welcome our speakers to the session. Joining us today, we have a telecom industry expert, Dr. Diong Seng, Vice President of Technical Services, ZTE Malaysia Corporation, Sdn Bhd. How are you, Dr. Diong?
Hi, Dr. Azlan. Hi, everyone.
Also joining us from MMU Malacca, Professor IR Dr. Tan Geok from the Faculty of Engineering and Technology. How are you, Prof?
Hi, Dr. Azlan.
Hi.
Hi, everybody. I'm fine.
Okay, we are so glad that you could be here today to share your thoughts and insight on telecommunication industry and quality of life. Let me first briefly introduce myself and our guest speakers. I received my BS degree in electrical and computer engineering from the Ohio State University, Columbus, Ohio, USA in 1998. And my master's degree in communication engineering from the University of Manchester, UK in 2004. In March 2012, I was awarded a PhD degree in communication engineering from Nagoya Institute of Technology, Japan. I have more than a decade industrial experience in telecommunication sectors. My research interests cover from coding theory, security in communication systems, signal processing, and AI for vehicular communication applications. Next, Dr. Diong Seng. He received his BSc from University of Malaya and the LLB from University of London. He later completed his MBA and PhD in accounting in UPM. Dr. Diong has vast industrial experience in the field of telecommunication engineering. In his 20 plus years of career life, he has been providing consultancy services to various telcos around the world, such as AT&T in the US, Taiwan Mobile, and Turkcell in Turkey. Currently, he is attached to ZTE Corporation, responsible primarily on technical related services to all ZTE customers in Malaysia. Last, Professor IR Dr. Tan Geok. He received the BE, ME, and PhD degrees, all in electrical engineering from University of Technology, Malaysia in 1995, 97, and 2000 respectively. He has been senior R&D engineer in Ep1 Singapore in 2000. In 2001 until 2003, he joined Docomo Euro Labs in Munich, Germany. He is currently academic staff at Multimedia University. His research interests include radio propagation for outdoor and indoor, outfit multi-user detection techniques for multi-carrier technologies, and AGPS. Okay, let me give you some quick background about the topic today before I invite the speakers. The technological innovations during the pandemic have been very instrumental so far, with most countries still battling severe health and socio-economic impacts. For example, countries like the US, China, South Korea, and many others across the globe are using digital technologies to track the spread of COVID-19, conduct quality contact tracing, and in some cases, using the mobile apps like MySejahtera, for example, to ensure adherence to containment or lockdown measures. Moreover, using advanced technologies like drones and robots, countries like China have managed to deliver essential medical supplies to even remote areas, thus ensuring the medical personnel are protected and also that there is reduced human to human contact. Technologies such as thermal sensors, smart helmets, and robots are now prevalent in different nodes like airports, subways, and other public places, and are assisting in detecting individuals who may have signs of the virus. Based on such contributions of digital technologies in fight against the COVID-19 pandemic and sustaining some economic activities, it is vital to emphasize the role of these technologies, specifically telecommunication technologies, in our lives, and to truly appreciate the depth and complexity of this field and thereby understand the opportunities it affords. It is pretty much an avoidable part of our life. Okay, to discuss this topic further, let's turn to our first speaker, Professor IR Dr. Tan Geok. Over to you, Prof.
Morning, Dr. Azlan,
Morning.
the moderator of today's session. And also thank you, ICEC, for inviting me. And also, very good morning to all the audience, okay, online audience. Okay, so so let me start my presentation. The PowerPoint, yes. Okay, so the topic I would like to share today is related to the sustainable wireless connectivity. Okay, next. Uh, the uh, the discussion will cover basically three main areas. The first is an overview on the current state of wireless connectivity. Then we will follow by the SDG and ICT, how we can relate the ICT to the SDG. And lastly, a brief introduction to my research activity in MMU. Next, so what is the mobile communication? In the wider sense, what is wireless communications? So based on the general understanding, okay, so the wireless communication allow us, okay, to communicate without the physical connectivity. So that is our general understanding. Okay, so next. So the wireless communication or mobile communication, okay, more specifically, allow us to communicate at anywhere, any places, anytime. You know, you can work 24 hours around the clock and to talk to anyone you like. Okay, so that is a beauty of wireless communication. Next. However, okay, especially during the COVID-19 pandemic, okay, so I mean that during this period, some issues regarding the internet connectivity, wireless connectivity, or the telecommunication services becoming a hot topic because you know, especially our students who are living in the remote area, they are not able to access to the internet services, so they are not able to attend the online courses, you know, in rural area, you see, and also in the remote area. So this will be the big challenge to our local domestic telecommunication industry. We hope this issue can be addressed very soon so that our children, our future generation will enjoy, or I mean to are able, especially to attend, they are not left out in terms of the education or online classes. So this is very crucial for us. And among the issue about the connectivity, lack of connectivity, okay, is there are many factors. So I just list down a few. Okay, so first about lack of infrastructure, especially in the those less developed area or country or region. So you know they require a huge investment to invest to build the telecommunication infrastructure. However, in the big city, you know, the facility are very modern and sophisticated. However, because the development is too fast, so the network planning cannot catch up with the pace. So more work need to be done so to improve the connectivity, the coverage issues. And next, the factors could be due to the commercial consideration, especially in the rural and remote area, and in the dense area. Okay, so means where especially in the shopping mall, in the places where there is a lot of crowd, so we also suffer network congestion. So because of network congestion, so it's hard for us to access to the network Okay, so then the last is about the last factor is about the public opinion. So now there are movement or campaign to against, you know, the mobile communication, wireless communication. So people dislike to see the communication tower nearby their residential area or the place where they work or place where they stay. Next. Next about the uh, SDG. So SDG is something new initiative from the United Nations. It covers 17 SDG. So the area, the coverage of SDG is very broad. It covers from poverty, zero hunger, good health, education, gender equality, clean water, until areas such as climate change and peace, justice. So the area is broad. So next, so the SDG is the 2030 agenda for sustainable development adopted by all the United Nations member countries in 2015. So uh, the according to the plan, so we will achieve all the SDG by 2030. So we see how maybe it is about 8 years from now. So and most of the member countries now are putting more effort to adopt and to incorporate or to absorb the SDG into their policy making, okay, into their industry and into their education. Okay, so the main purpose or main objective of the SDG is to ensure peace and prosperity for the people on this planet. Okay, and also not only people, but we want to take care of the health of this planet, take care of our environment, and we want to control the CO2 emissions. We want to use more greener energy, renewable energy. So this will be part of the agenda, okay, of the SDG. Next. So ICT is very important. It's a catalyst for achieving all these SDGs. And ITU recognized the importance of the SDG and start contributing proactively into some selected SDG. For example, SDG number 3, number 8, and number 9, especially number 9, because number 9 SDG is related to infrastructure. So ITU has started a lot of work and to carry out study to see how this infrastructure, telecommunication infrastructure, can be improved so that it can provide full coverage or better coverage or improved coverage to all the population. Okay, so and then other SDG is SDG 11, 12, and 17. Okay, next. Okay, so based on the study in ITU, so we have almost half of population without the internet connection. In other words, they are offline. So the study is carried out in 2019, based on the report in 2020. Okay, so I mean this is 2 years from now. So and as I mentioned, during the pandemic, you see, this issue become more crucial because we are not allowed to go out. We need to do, to work from home. We need to attend the classes, online classes from home. So, and this is a big challenge, okay, for most of the country, or many country, okay, on this planet. Next. Okay, so to solve this problem, okay, based on the study done in 2019, so the ITU come up with another study to see how we can actually improve the digital gap among the various community. Okay, so the study is focusing on the last mile connectivity. Okay, so from the end user point of view, the telecommunication services actually, or simply a wireless communication, because the last mile connectivity basically from the end user point of view is a wireless connectivity. So I don't see we still need to carry a cable together with our laptop or handphone, connect to the socket on the wall to access to the internet. I don't think we still do that now. Okay, so that's why the last mile connectivity we are discussing here is the wireless connectivity. So based on the report, okay, from the ITU, say the most cost-effective way to close up or to improve the digital gap is a wireless connectivity. How we can install the wireless infrastructure, okay, to reach out those remote area, to provide coverage to the rural area, so that our student, our children can attend the online classes. Okay, and next. Okay, and beside the infrastructure, so now we are talking about IoT, IoE, IR 4.0. Okay, so the key component, the key driving force in all this IoT, IoE, Industrial 4.0 is the wireless connectivity, because we have so many sensors, devices. We need to connect, need to communicate. So the only way is through wireless connectivity. So that's why we will foresee, if the 5G technology can drive further the development of the IoT, IoE, and IoT. So 5G means wireless connectivity. Next. So now I would like to share a bit on our research in MMU. So I selected a few, three, related to the topic. So first is about the channel modeling for fixed wireless access and in-building coverage, the 3D modeling, and transparent filtering antenna. So this is a definition. So somebody call FWA, somebody call radio local loop, somebody say wireless local loop, but the meaning is the same, to provide wireless services to the fixed point. Okay, so the objective is to conduct the 3D modeling and then to carry out the measurement. So our research team is a Madam Nozira, the PhD candidate, and Madam Ika, the master candidate. And this is the part of the work. So we do the 3D modeling in the real environment, outdoor environment, in the rural area. And we have data collected from more than 50 microwave link, point to point, okay, point to point link. And then the IBC channel modeling. So we developed the 3D channel modeling based on ray tracing method. And then we also carry out the measurement, the frequency range from the 6 gigahertz, 28 gigahertz, and 38 gigahertz. And we had done the comparison, and this the objective is to develop and to improve the conventional ray tracing modeling method, and then to develop tools so that can be used for future modeling and computation. So these are the process involved. Okay, so as you can see here, the tools allow us to trace the multipath propagation step by step, progressively. Okay, next. is about the transparent filtering antenna. So as you know, as I mentioned in the first few slides, so uh, indoor area are suffering, the coverage issues because of due to the obstruction of the building or the material, and also due to also suffering the interference between the downlink and uplink from the different from the neighboring station, okay, or neighboring access point. So we have a two issues here. One is interference, and another one is coverage issues. So this antenna will solve basically three uh three uh three issues. One is to solve the interference issue because we integrate the antenna filter, RF filter into the antenna, and uh, we design the antenna to improve the coverage. And third one is the antenna is transparent, so it is invisible. So it is invisible, so means it's easy for the telecommunication infrastructure embedded or fixed into the landscaping. So now people are a bit worried when they see the antenna at the telecommunication tower or on the roof. People start worry, and they against basically this. And our solution basically can address all these issues. So in the conventional solution, so when you suffer interference, so you need to add the external RF filter. So when you add the external RF filter, it will cause problem into the additional losses. So our solution is about the integrate the filter and then into the antenna and make it transparent so that it's easy for the network operator to incorporate the antenna or to install the antenna without notice by the end user. Next. So this is the prototype we developed earlier. So and you see the patch itself actually has quite, sufficient high transparency, almost 90% of transparency. Okay, so this is a real antenna, real prototype we have developed, and that's all from my side. Okay, thank you, and over to you, Dr. Azlan.
Okay, thank you, Prof Tan, for your wonderful and insightful sharing. Okay, a quick note. I think I realized that we are not streaming live from our FB lives due to some technical glitches for this webinar. So, but you can still tune in to our YouTube channel. I think the link has been given in the chat box. Yeah. So anyway, again to our audience who are watching us live, you can type in your comments, question in the chat box. We will entertain them right after Dr. Diong's talk. Okay, Prof Tan actually has been championing the sustainability cause in MMU for years and has an active research in this field by the name My Sun. Okay, this project has been co-funded by the European Commission involving many Malaysian public universities and some university partners in Europe. Okay, so I think it's good that I'm also part of this project. One key highlight from Prof Tan's talk is the transparent antenna, actually, which is considered to be a popular green communication feature. One interesting application is from Prof Tan's mentioned just now, for fixed wireless access, okay, in 5G communication networks. As we all know, high frequency radio waves, such as 5G millimeter waves, for example, can receive and transmit large amounts of data at high speeds, but their high linearity and attenuation make it difficult for them to reach indoor areas, as mentioned by Prof. Yeah. So this hampers the creation of communication areas inside buildings using outdoor base station. One proposed solution is using transparent antenna mounted directly on the window glass, for example, enabling the indoor Wi-Fi area to be created while maintaining a high level of lighting without compromising the landscape. So it's quite interesting, I think. So now most of us have heard about the coming of 5G in this country. This is actually a real buzz in the coming months. Okay, I think most of us have mobile phones with 5G capabilities, even though they are slightly expensive. Yeah. To explore this subject, we would like to dig the potentials of this technology, what it has to offer. So let's turn to our second speaker, Dr. Diong Seng from ZTE Malaysia. So hopefully he's going to give from the industrial lenses. Please welcome Dr. Diong to the stage. Over to you, Dr. Diong. Unmute, Dr. Diong. Please unmute. Yeah. Still no sound. Probably, yeah. I still can't hear you. Still can't. Or you. Probably you can talk direct to your laptop, Dr. Dion, without the earbud. We still can't hear you.
Dr. Diong is muted.
Can you try unmute? Or can you try access? Okay, yeah.
Can you hear me now?
Yeah. Okay.
I'm sorry for that. Okay. Okay, let's start. Okay. Sorry for the glitches. Okay. Thanks, Dr. Azlan. Very good morning to all of the audience. Thanks for having me here today. It's my pleasure to be able to share in this noble forum this morning. Before I start, I would like to wish all our friends here healthy, safe, and peace, especially in the holy month of Ramadan. Okay, let's start. Can you project my slide? Okay, next. Okay, for my sharing, the agenda will be the flow of my agenda will be like this. I will do a bit of definition of telecommunication and quality of life. Then I will go into mobile technology evolution and 5G impact on the lifestyle. And last but not least, there's going to be some reflections and challenges of the coming mobile technology developments. Next. Okay, a brief definition of telecommunication. I think this one is quite straightforward. Uh, Telecommunication means the methods of electronic transmission of information over distances. So we have all kind of communication methods, but not all of them can be categorized of telecommunication. For example, we have some ancient ways of communication like cave paintings, drum signal, smoke signal, carrier pigeon. All this actually is the way to communicate between people, but however, they don't have the elements of electronics or certain power involved. So this shouldn't be categorized of telecommunication. Okay, telecommunication actually it was developed actually in near probably 150 years from now. So it evolved actually from telegram, TV, radio to the fixed line, and eventually to the era of mobile communication, mobile world that we are in now. Okay, next. Okay, the quality of life, actually, this is difficult part for the definition. So I get the definition from Wikipedia, which is defined by WHO. An individual's perception of their position in life in the context of the culture and value system in which they live and in relation to their goals, expectation, standards, and concerns. If you look at the definition terms here, it seems like all of the words actually are relative and subjective to individual. For example, individual's perception. So this is very individual. And in life, in the context of the culture and value system in which they live in. So this is another part of the very relative kind of the definition. So, and in relation to their goals, expectations, standard, concerns, all those are very individual. So this is the reason that I say I mentioned just now, quality of life is difficult to be generalized, to be defined. So it can be different for different people. So if you look at the two pictures that I put on at the bottom, so left-hand side, the Mona Lisa piece of art. The other one is the NFT kind of the art pieces. So I think for an art lover, so you will find that by looking at Mona Lisa painting, probably you will have your spiritual fulfillment. But for an NFT or this new asset classes investor, so those NFT painting probably might attract them more. So this is a difference. So this is the reason that we say the quality of life is a bit subjective and difficult to be generalized, to be defined, yes. But one thing for sure is the development of communication technology will definitely change our life or change our lifestyle. So no, I think to change our life is a bit too harsh. But I think to change our lifestyle or to change the way that we live, I think probably is a more appropriate description for that. Okay, next. Okay, mobile technology evolution. So from first generation to fourth generation. Next. Okay, evolution of mobile technology. So first generation technology actually marks the beginning of mobile communication. In 1973, Motorola created a mobile phone which kickstarted a change of developments that transformed communication forever. So meaning is Motorola invented the first mobile phone which transform the communication from non-mobile to mobile. So this is from 0 to 1. So this marked a very important historical date for historical events in the mobile communications technology. Then the process of converting analogy to digital signals manifested a significant change, and this marked the beginning of the second generation 2G in the field of telecommunications. So like what I underlined, so mobile for everyone. When come to the GSM and CDMA is allow cheaper mobile terminals to the user. So it's not like the first generation mobile phone. It's basically a brick that you carry around. It cost at the time, I remember one of my relatives has one. It costs like close to 20,000 ringgit at the time. So you can imagine when come to 2G, so you can easily get a phone with 1 to 2,000 ringgit at the time, still consider expensive, but I think it's already a lot cheaper than first generation mobile phone. Then after a decade of 2G, the demand of high data transfer increased, which lead to a new generation of wireless technology, which is used in many countries even today. Unfortunately, or not, it shouldn't be unfortunate, but I think just for your information, in Malaysia, we have already shut down 3G network. So probably we don't need to talk too much on 3G. But again, 3G network is the foundation of mobile internet. So we start offer the mobile internet services in 3G network. So 3G network actually is influence the developments of the terminal itself. So during the 3G era, we start to see the smartphone emerging in the market. Okay, then let's come to 4G. 4G actually we define it as fast mobile internet era. So the fourth generation technology provides the same features as 3G with a few additional services. But the extraordinary increase of downloading speed from 2 Mbps to approximately 300 Mbps for now in practical world. So of course, when it comes to theoretical internet speed, it can go a bit higher. So for 4G network, it enables people to study, play, work, and shop everywhere they want. As a consequence, people will be liberated from the limitations of restriction of space and be able to more freely choose where they want to be. So this is like what Prof Tan mentioned. So during the pandemic, okay, this is actually we can say this 4G technology actually it really saves us from our this pandemic restriction for past 2 years. Okay, then come to 5G. We define the 5G as the era of internet for everything. Okay, well, the word is a bit blur for me. I need to open my own slide. Okay, 4G actually is the internet for everything. So we start off connecting of everything. So instead of limited devices can be connected to 4G networks. Next. Okay, then the subsequent part, we will focus a bit on the 5G, what 5G can offer. So service evolution from 4G to 5G. So this is basically to compare what 4G offered and what 5G can do. So if you look at 4G, so the MBB stands for mobile broadband. Like I mentioned just now, I think the maximum speed for 4G probably can go up to around 250 to 300 Mbps kind of the limitation. And in 4G, you have limited IoT devices can be connected to the system. Okay, so this is for the 5G. This is for the 4G. For 5G, we have three important pillars of the breakthrough. First, of course, we go for MBB. So we thought we name it enhanced MBB. So for the speed itself, we can easily go up to 1 point something gig for the C-band, and probably from the millimeter wave, you can easily go up to close to maybe 10 gig kind of the mobile internet speed. Then for 5G, they are introducing some new architecture to support the eMTC. The MMTC stand for massive type communication. So this is a machine type communication. So this is basically for IoT, and it can connect a lot more devices than 4G can offer. So then we go for this very low latency services, like for example, the autonomous vehicle kind of services. You need to be, the response time need to be very, very low, and the requirements is very stringent. So you can imagine the accident can happen in a blink of eyes. So the latency, the response time actually is important in order for to offer this kind of services. Next. Okay, let's go into the 5G use cases. So I would like to put on a few new application. Actually, less people really relate this to 5G use cases. Okay. First is the decentralized applications, such as blockchain. Blockchain is one of the decentralized and some other decentralized application and approaches. So all this actually running on distributed computing resources among a plethora of devices. A lot of devices actually running the distributed, all those processing actually distributed in a lot of devices. Therefore, there's high degree of the network participation required in order to support this kind of activities or processing. So 5G enables mobile devices to run light nodes through mobile data. At the moment, actually, most of the data crypto mining, actually, we are using the fixed terminal, fixed computer, and with the landline. So, but I think in the future, we can use the mobile devices to run as light nodes. And 5G allows very big numbers of devices to communicate through unified data set. So this is actually the decentralized application. Decentralized application actually run peer-to-peer, and is transforming the way we conduct everyday life, from payment system to the allocation and consumption of resources. Next. Okay, another interesting use cases, this augmented reality, virtual reality, very high, ultra high def video. So actually all this, they are related to my subsequent slide that talking about the Metaverse. So this is one of the heatedly debated topics recently. So for this AVVE, like for example, you can view with the 5G network, you can view the live video, which can go up to 8K VR streaming live, and for the entertainment and shopping and education. So if you look at that, the VR crowd game. So you just need to use the VR display. You don't need the game console for that. VR sightseeing, tourism, and some other thing. So at the moment, the services offer actually is still quite 3D based. What we proceed there is the people look at the internet. We are looking at the internet. Next, then I think we let's go to something more exciting. So metaverse. What does it mean by metaverse? Actually, in short, metaverse actually is VR in everything. What is a metaverse? A metaverse is a network of 3D visual worlds focused on social connection. The metaverse is understood as a graphically rich visual space which people can work, play, shop, and socialize. I think the second statement is very important. The metaverse is a 4D of internet, and it can be thought of an internet that you are inside of. So this is a keyword, you are inside of, rather than once you are merely looking at. So the previous VR, AR that I mentioned, for example, the virtual tourism, you just look at you just do the sightseeing. But with the metaverse, with the VR in everything, so probably you can feel like, for example, you look at the London Bridge, you can feel the breeze from the Thames River. You can feel the coldness of the weather in Hokkaido. So this is what actually is the metaverse aim for. So this is another dimension, the fourth dimension that we can be in. So basically, we can touch, we can feel. So this is the ultimate goal for. I think ultimate is a bit harsh. I think probably this is the goal for this the development of this VR technology, which we define it as metaverse. Okay, key technologies that empower metaverse. Okay, AR and VR can give us an immersive and engaging 3D experience. So this is the foundation. This is the foundation entry point to the virtual world. So this one I think is given. Then we need the blockchain technology provides a decentralized solution for digital proof of ownership. I think this is very important. Digital proof of ownership. You bought something in the virtual world, so you will need to have the proof of ownership. Digital collectibilities, transfer of assets. So you want to sell, you want to buy any asset in the virtual world. So blockchain is the technology that to help you to protect all those things. So another thing is the cryptocurrency enable user to transfer value. So probably in the virtual world, you need to buy anything, you need to sell anything. You need to pay in crypto, and you will receive crypto also. So to transfer the value while they work and socialize in the 3D digital world. Okay, then we talk about IoT, artificial intelligence, 3D reconstruction. I think this one, we skip for this time because due to the time constraint. So we are talking something more related to telecommunication. IoT, why IoT is so important in virtual space? Okay, the reason to have IoT is to collect and to provide data from the physical world. So then you transform it to the virtual world. So this will increase the accuracy of the digital representation. So this is an important part of the IoT. Okay, then the final part, we need the 5G connectivity. Why? Okay, the experience in the virtual world are limited by how far they can push VR and AR experience. So again, we come back to VR and AR experience, how to improve the AR and VR experience. They need faster network with lower latency that can allow huge amounts of data jibbing between cloud servers and their devices. So 5G will start to open up possibilities like VR experience that include the sense of touch. I think also this is the important part. So we will need 5G to support the experience, to enhance the experience of the VR and AR experience. So in order to for us to move towards the Metaverse era. Okay, next. Okay, so again, we back to the more conventional business. So it's to us actually it's quite new, but in certain part of the world actually this doesn't. I think this actually doesn't consider new anymore. Like for example, we use drone to transport the medicine, to deliver the parcel that you we order online. So actually this already happened in a certain corner of the world. And of course the autonomous car, the requirement of autonomous car actually, the technical requirement of autonomous car actually is quite stringent because it's something to do with the human life, the safety on the road. So like I mentioned just now, the bandwidth requirements is high, the latency requirements is high. So we will need the 5G technology to support the autonomous car system. And let's go back to the drone. For drone, actually, another very important element is the positioning. So this one, I think, is one of the, I think probably one of the research area that probably someone may want to look at the positioning, how to use the 5G to provide you a more accurate positioning. Okay, next. Okay, some other suggested use cases for 5G. In Malaysia, actually, we have already adopted, I don't say it has already widely used, but I think in certain area we have already had a proof of concept. Okay, like for example, smart cities, smart parkings. I think quite some people are working on the smart parking, smart meter. I think smart meters is one of the thing that that has already been deployed in Malaysia. Like for example, TMB and the Selangor. I think they have, especially for TMB, they have already serving the notice to replace the existing meter with smart meter. Okay, then we have a smart water control, smart industrial, all those kind of thing. Okay, next. Okay, after we have all these use cases for 5G, then you might ask, what about 6G? 6G. So this is another interesting topics. However, at the moment, I think it's a bit too early to tell what will be how's the 6G looks like. Okay, I just highlight a few points that the direction that they are going for, the industrial is going for. So in 6G, we are going to use the terahertz frequency, high bandwidth. So a bit of advice to Prof Tan. I saw your research topic just now. You mentioned, I think mainly it's just go up to gigahertz. So probably you can explore a bit on the terahertz kind of the research. So okay. Then 6G, I think one important, very important element is to exploit low orbit satellite and area and terrestrial platforms jointly together to improve the radio access capability. For 5G, it will still go into the convention way of building the coverage based on the tower that's available, or they are building the new radio tower to provide the coverage to the surrounding areas. However, for 6G, so they are going to incorporate satellite into the system. So by doing this, basically they are leaving no blind spot for the mobile coverage, for the 6G coverage. So for example, in 5G, if for 5G services, that's not possible for us to build a radio tower in the middle of a Pacific Ocean. So those crews or those logistic ship, so they are cruising on the Pacific Ocean, so they might not be able to, they are not able to enjoy the 5G services. So this defeated the purpose of internet for everything. So these cruises, we want them to be connected also. So this problem will be solved in 6G. So this is one of the important elements for 6G. In terms of the commercialize of 6G, the paper say it's going to be 2030. Okay, let's see what will happen. Okay, next. Okay, last but not least, let's do some reflection and to put up the challenges that we have by implementing 5G or even in the future 6G. So the privacy, I think, is always a key concern. So for example, if normally when we want to go anywhere, we use Google Map or we use Waze to navigate, to help us to navigate. So when you use this application, actually all your footprint, anywhere that you go actually is recorded by Google. So this is the privacy concern. So we will need to ask ourselves to what extent we are willing to sacrifice our privacy in order to enjoy this kind of convenience. Okay, so this is the first reflection that we will need to really seriously look at. Then the second one will be the cybersecurity. So as you know, in 5G network, everything will be controlled by 5G. So the way you drive on the road, so your life actually is in the hand of 5G. Should I say in the hand of 5G? 5G has any hand? Okay, that's different story, but you know what I mean. Again, all those smart city kind of the application actually is affected all of us. So what happened is somebody attacked into the system, it will screw up the whole thing. Okay, again, another one, the question might be asked, you build a brand new network, so what is the issue of sustainability? I think Prof Tan has touched it quite substantially just now, so I will just skip this part. Okay, that's all for my sharing. Thanks everyone for your attention and your patience also. Thank you. Over to you, Dr. Azlan.
Okay, thank you, Dr. Diong, for your exciting sharing. Actually, Dr. Diong is no stranger to us at FET, MMU Malacca. He's been our Industrial Advisory Panel, IAP member for our Telecommunication degree program for many years. And through him, we have successfully initiated some industrial engagement and collaborations with ZTE. More importantly, this partnership has led to the establishment of the world-class ZTE MMU Training Center, purpose-built for the faculty at MMU Malacca. Okay, the lab, which has been developed since 2017, provides an opportunity for students and industry players to explore and extend technological innovation and vocational training. If you need more info on this, please do not hesitate to contact us later. We are sorry we have no time for the Q&A session because we got to stop at 11:45. I think we have to conclude or wrap up the session. But before that, I would like to invite again Dr. Diong for his closing remark, and then followed by Prof Tan in a couple of minutes. Yeah. Okay, over to you again, Dr. Diong, for your concluding remarks.
Okay, thanks, Dr. Azlan. I think from our part, from what the title of today's thing, uh, the title for today's the topics for today's speech, I think, um, of course, I think we can conclude that to a big extent, the development of uh, the progression of the telecommunication industrial, the technology actually, to big extent, it improves the life, the quality of life for most of the people. But again, we are facing some other challenges like we will need to sacrifice our probably our privacy, and we are exposed ourselves to the cybersecurity issue. So this need to be addressed. Yeah, I think this is a thing that will need to be addressed in order for us to progress more. Okay, thank you.
Thank you, Dr. Dion. Okay, Prof Tan.
Okay, thank you, Dr. Azlan. So I have 2 points to stress here. I mean, to conclude my actually the presentation, okay, the discussion here. So first point is about the quality of life. So the way to measure, to gauge the quality of life, okay, and the state of economy development, okay, is through the indicators. Okay, there are so many indicators, and telecommunication infrastructure is one of the important indicator to measure, okay, the state of development, economic development, and also the quality of life. Okay, so these they are important. The relationship between these two items. Okay, the second point is about the sustainability. Okay, the sustainable development. Okay, so you will see soon. Okay, in the next few years, so the SDG will actually affect the way we do our work, the way we do business, the way we carry out our research. So SDG will be adopted in all area. Okay, uh, in the and will be actually will affect the policy maker also lah. So if you do not adopt sustainable practices, sufficient sustainable practices into your business, you will feel very hard to do business in future. And also similarly, if you want to do research, if the sustainable practices is not sufficiently observed or adopted, so you feel a bit hard for you maybe to secure a grant, maybe to carry out your research. So this will be the our things that we need to bear in mind, and to observe and to or else to adopt into our future activities. So that's all from my side. Thank you, Dr. Azlan.
Okay, thank you, Prof Tan. Now we have come to the end of this Insights High webinar session. Definitely, we have so many things to explore related to this topic, but we don't have time for that. I suggest all of you to check out our webinar series in the future. Okay, I would like to take this opportunity to express my gratitude and thanks to our guest speakers, Dr. Diong Seng. Okay. Vice President of Technical Services ZT Malaysia Corporation Sdn Bhd, and Professor IR Dr. Tan Kim Geok for your invaluable talks and exciting presentation. Also, many thanks to the organizer of the webinar, Industrial Collaboration and Engagement Center, ICEC, under the Research Industrial Collaboration and Engagement RISE Division, co-organized by the Faculty of Engineering and Technology. Also, do not forget MMU Studio, Strategic Marketing Department under Strategic Marketing Admission and Recruitment Smart Division, and the technical support team for making this insightful webinar conducted smoothly. And last but not least, our audience for your interest and participation in this webinar. We also like to apologize for the hiccups we experienced, in our FB Live. Hopefully, this will not happen in the future. Thank you, everyone. We appreciate your being here. Have a nice day. Ramadan Mubarak. See you again. Bye.
Okay.